Hello everybody and welcome to the second lesson of chapter 4 as part of the course for advanced functions. Today we'll be covering a new and old topic technically, which is the trigonometric ratios and special angles. Of course, we're going to be covering trigonometric ratios, special angles, and also trigonometric ratios of multiples of the special angles. So overall, this is just rather easy and simple stuff, but again, there's a little catch to it. So let's get started with the trigonometric ratios. So we've been working with them for a couple of years now, starting in grade 10 for most of you, but by now you should know how to use them and how to derive them. So the 6 trigonometric ratios we have are sine, cosine, tangent, cosecant, secant, and cotangent. And all of them you know how to derive, right? So for this chapter, or for all of this course essentially, there's a little bit of a catch, and that's we're gonna start using them with radians rather than degrees. That's it. That's all that's new. So essentially, the biggest thing here is to actually just forget everything you've learned about these 6 ratios while using degrees. Because you're not going to need them. You're not going to be converting. You're going to be using them essentially with only radians. So the biggest mistake you could make in this chapter is to constantly try to convert between degrees and radians, which is personally my favorite thing, since our first chapter was just teaching us how to do that, but now you just need to not do that anymore. But yeah, essentially, since the rest of the chapter will be following just radians with these 6 ratios, you're not gonna have time to constantly convert between one and another. Plus, as you go into graphing, it's just gonna get so much more complicated. So if you don't understand how to use radians now, the reality is you're not gonna do that well in this course. So, in case you've forgotten, here's a quick rundown of the trigonometric ratios. You might remember SOHCAHTOA. That's exactly what it is. We know that tan theta is equals to the opposite over adjacent. Sine theta is opposite over the hypotenuse. Cosine theta is equals to the adjacent over the hypotenuse. And then our inverse trigonometric ratios are equal to the following. Cotangent is equals to 1 over the tangent of theta, which is equals to the reciprocal of what we had before, which is adjacent over opposite. Now the cosecant is equals to 1 over sine theta, which is again the inverse, so we have the hypotenuse over the opposite side. And lastly, our secant is equals to theta, and that is equals to 1 over cos theta, and that is equals to the hypotenuse over the adjacent side. Personally, what I like to do while thinking about these is that cot is the only one that has a t, therefore it has to go with tangent. Then these two get a little bit tricky, but essentially you have to remember if it starts with a c, it actually corresponds to the opposite letter, which is s. So c goes to s and s goes to c. Therefore, cosecant goes to sine and secant goes to cosine. Okay, now let's move on to special angles. Again, last year you should have learned about the special angles such as 30 degrees, 45 degrees, 60 degrees. I'm pretty sure 90 degrees counts and 180 does too, but I don't know. They're just really simple to figure out, so I didn't bother writing them. The properties of these angles will carry over when you convert them to radians, which is wonderful because that's the only thing we're going to be working with, right? So now our special angles are the following: pi over 6, pi over 4, pi over 3, pi over 2, and pi. It might get a little bit confusing about why they're this, but remember, this is the only time you need to actually remember the conversion. Or let's just say pi is equals to 180 degrees, right? So 180 degrees divided by 6, oh, that's 30 degrees, that's good. 180 divided by 4, that's 45. 180 divided by 3, that's 60. Pi over 2, that's 180 divided by 2, which is 90, and pi is 180. So that's how we're getting these special angles. We need to be careful about pi over 6 and pi over 3, because sometimes I would mess them up and be like, oh wow, this ends with a 3, therefore it has to be 30. No, you can't do that. It ends with a 3, therefore it has to be 60. It's a little bit confusing, but again, with practice, you just master it. So we can analyze the properties of these angles using the circle, the unit circle, and the cast rule. I know you guys probably really like those in grade 11, but again, we're back here. We're doing it again. So, while using the unit circle, we can also analyze the trigonometric ratios of the multiples of the special angles, which is our next slide. But essentially, I will be showing you how to use the unit circle and why it might not be the best tool out there right now, because it takes quite a while to remember. But overall, again, I'll just be showing you it and teaching you how to use it. Okay, so today we'll actually be looking at the unit circle. So for this, I'll actually be showing you how to derive some of the values. This is again for cos and sine, but I'm also gonna remind you of some things you learned from last year. For example, the first thing that you should definitely remember is your two special triangles from grade 11. Sorry, they're not really the best, but the first one had a base at 1, a hypotenuse of 2, and we found out that this side was the square root of 3. Then our second one was one with both sides equals to 1, and the hypotenuse is equals to square root of 2. You should also remember this was 30 degrees, sorry, this was 60 degrees, 60 degrees, 30 degrees, this was 45 and 45. So from here, what we actually remembered, what you should remember, or what you can easily derive, is for example, for sine 30, we have sine 30 is equals to the opposite over the hypotenuse, which is equals to 1/2. For sine 45, so at the second angle, what we have is opposite, which is 1 over the hypotenuse, which is equals to 1 over square root of 2. And then we have sine 60, which is equals to, again, opposite over hypotenuse, which is equals to square root of 3 over 2. We could also do the same thing for cos, which we find would be actually just the reverse order. So cos 30 is equals to square root of 3 over 2. Sorry, I wrote an S. Should write an C. Cos 45 is equals to 1 over square root of 2. And then sine, again, I keep writing the wrong one. Cos 60 is equals to 1 over 2. So that's what we learned last year, but how can we apply that to our unit circle here? So first of all, I just want to talk about some of the values that were given here. For example, the 1, 0, the 0, 1, the negative 1 over 3, and the 0, negative 1. So to get these values is actually pretty simple. So let's think back of what the unit circle is actually representing. So our unit circle is helping us find cos and sine. What is sine equal to? Sine theta is equals to the opposite over the hypotenuse. So in our case, we know for a unit circle, everything has to be 1, right? So all the radii are 1, therefore the hypotenuse is 1. Our opposite arm is going to be given opposite of the angle that we're having here, which would be the y-coordinate, right? It would be the y value. Therefore, we found that sine theta in the unit circle is just equals to y. Similarly, to find cos theta, we actually have the adjacent over the hypotenuse, which is actually equal to the x value over 1. Because again, let's look at this over here. What would be our adjacent leg? It would be this one, therefore it's the x value. Therefore, cos theta is equals to x. So if we have a right angle triangle that we could build anywhere here, so for example, let's build one at 45, what we actually have is that x and y. Again, we know what those are. Those are representing our sine theta and cos theta. But we also know through the Pythagorean theorem is that since we have a right angle triangle, x squared plus y squared is equals to 1. From here, it's quite simple for how we're getting these values. For example, over here, our x coordinate, let's say we don't know it, but we know that y doesn't exist because we're on the x coordinate or the x-axis. Therefore, y is equals to 0, so x squared is equals to 1, so x is equals to 1, or x squared is equals to, or x is equals to -1. So we got these two values. The same thing goes for the y-axis. So we solved that little mystery. Similarly, the 45-degree angles or the pi over 4 angles are really simple. Since we know again that this is 1 and both our angles are now 45 degrees, so this one and this one are 45, what we find is that we have either 2x or 2y values. So I would just write 2x, since we could just express this as x squared plus x squared is equals to 1. So x squared is equals to 1 over 2. So x is equals to plus minus square root of 1 over 2. We could simplify this and rationalize the denominator, and we would actually get plus minus square root of 2 over 2. So that was our value for sine and cos. So when we need to first of all also apply the cast rule. If you don't remember how it goes, it's not that difficult. Just remember that in your first quadrant everything will be positive, so the A is there, and then you could just spell cast. You know, C-A-S-T. We're good. So if we have our x value is equals to positive and or negative, and here it has to be positive, so we actually get square root of 2 over 2 over here. And also, since we said the x and y values are the exact same for 45 degrees, that means that this is 2. Square root of 2 over 2. Now, we could go into our next values. So for s, that means only sine is positive, everything else is negative. So what we would actually get is those exact same values, but cosine has to be negative, so we get negative square root of 2 over 2, and then positive sine values, which is 2 over 2, square root 2 over 2. Here, tan is negative, so tan is positive, sorry. So both of these values have to be negative. And over here, our cosine is positive, therefore, I wrote that in the wrong place. I just realized, sorry about that. Let's rewrite that. Negative square root 2 over 2, negative square root 2 over 2. Now we have our c, which is cosine again, is positive. Therefore, the first number is positive, and then the second number has to be negative. Now we got 8 of our values in the unit circle. Next, we have our 30 degrees and our 60 degrees, which is respectively pi over 6 or pi over 3. So, first, let's look at pi over 6 or 30 degrees. Again, using the definitions we found last year, we could easily say that sine 30 is equals to 1 over 2. However, there's one little problem. First of all, let's look at our triangles over here. Our hypotenuse here was 2, and here it was square root of 2. Therefore, to actually find the values in the unit circle, we would have to divide our first triangle by 2. So our first triangle, I'm gonna do it over here. First triangle was 1, square root of 3, and 2, but now it has been transformed by dividing every side by 2 into 1/2, 1, and then square root of 3 over 2. With that, we can now actually again do the same problem. So sine 30 would be equal to the opposite, so this is 30, opposite over the hypotenuse. So that would equal to sine 30 is equals to 1/2 divided by 1, which is equals to 1/2. Therefore, we have found that our first, at sine 30, it's equals to 1/2. So we're all good there. Now, let's look at our next part, which would be our cosine. Cos 30 is equals to adjacent, which is square root of 3 over 2, again divided by 1, which is equals to square root of 3 over 2. So we found that this is square root of 3 over 2. Similarly, for 60, we're actually just reversing the sine and the cosine values. Because again, let's look at 60 or pi over 3. Our opposite is now square root of 3 over 2, which used to be our adjacent. And our adjacent is 1 over 2, which used to be our opposite. Therefore, we're just reversing these values. So what do we get? We get 1 over 2, and then square root of 3 over 2. Now we're all done with our first quadrant, so let's move to the second one. Again, for these, all you have to do is just know the cast rule. So for example, our sine is always positive. Therefore, all of the values we had before are now negative when it's dealing with cosine. So we have negative 1 over 2 and then positive 3 over 2. Over here we have negative square root of 3 over 2, and this is positive 1 over 2. Now for t, everything is negative, since again we know that tan has to be positive, but we don't have tan in these coordinates. Therefore, we're just going to write everything with a negative in front of it. So we have negative 1 over 2, square root of 3 over 2. And then we have negative square root of 3 over 2 over... Now let's look at t. Again, t means that tan is positive, but we don't have tan in these in this unit circle, therefore we don't care about it. Here you just need to be careful about how you're copying over your data. So for example, since here what we were doing was actually saying that this is getting flipped to that side, right? Here, again, we're essentially flipping everything on the x-axis. So now instead of it being this corresponds to this, this actually corresponds to this. Therefore, since everything has to be negative, we get negative square root of 3 over 2, and then negative 1/2. Now we have negative 1 over 2, and then negative square root of 3 over 2. Again, we're all good. Now we're again copying over these values, just flipping them on the x-axis, or you could take these values and flip them onto the y-axis. But either way, you should get the same answers. So here, only cosine is positive, therefore we get square root of 3 over 2 is positive, but we have a negative 1/2. And over here, we get positive 3 over 2, and then negative, it was 1/2. Yeah, I'm positive 1/2, and then negative square root 3 over 2. These are all the values you essentially have to know for the unit circle. However, if you don't want to remember the full unit circle, you don't have to. I have a little simple life hack that I will show you in a couple of seconds. So okay, with these values, there's a little life hack you could do to just help you remember them easier. So for example, let's look at our first quadrant. What did we see here? We see, if you have a keen eye, a little pattern. So first of all, everything in the denominator is over 2. Right? So that would be our first step, to just write 2's for everything. Then our next pattern that you might see is that we have 1, 2, and 3 in the numerator. So we have 1, 2, 3 going this way. Then as I said, you just flip them for your sine values. Therefore we have 1, 2, 3 going that way. Next, you could actually just take the square root of the numerator for everything. The only thing that doesn't have a square root is actually 1, because the square root of 1 is 1, therefore we don't need to write it. Everything else keeps a square root. So we're done with those values. Now we could just, depending on where in the circle you are, just apply the cast rule and get your new values. Also, the way that I like to think about it when I was actually studying this is again with these little triangles. I know everybody says that they're kind of useless by the time you learn what the unit circle is, but I personally just adore them. Again, you just need to remember what those angles actually were. So if this was 30 and this was 60, well, sorry, that was a really interesting 60. This has to be square root of 3, this has to be 1, and this has to be 2. Now, also, for this unit, we also have our 45 degrees, right? Which is just 1 is square root of 2. Since we're no longer going to be dealing with our degree friends and only with our radians friends, we can just start remembering these values differently. So instead of saying 60 and 30, we need to get into the frame of having our radians. So 60 degrees is actually pi over 3, and 30 degrees is actually pi over 6. It gets a little bit confusing if you're trying to recall what the values are, because for example, you had pi over 3 is equals to 60, but then pi over 6 has a 6, but it's equals to 30, so it gets a little bit confusing. So personally, I just like to do some quick mental math, and I know that pi is equals to 180 degrees, therefore pi over 3 is 60. That's personally all I have to do. It takes like 3 seconds max for you to remember or to calculate what that value is, and you're most likely never going to make the mistake. Again, we also, from here, we could just find out what our values are. You could just quickly write them, right? Pi over 3, if it's sine, pi over 3 is equals to opposite over hypotenuse, we're good there. And then if we have cos, pi over 3, we have 1 over 2. Again, super fast, we don't have to care, and those are the exact same values that we were getting here. Then, anything else you need to do? No, not really. For 30 degrees, you could just flip the values you just found, and you're good. For 45 degrees, it's actually the most simple one. It's just 2 numbers over each other. So for example, here we would have had pi. Let's draw it with our new pi values, or our radian values. It's pi over 4. So 1 square root of 2. So sine pi over 4 is actually equals to 1 over square root of 2. Then we rationalize the denominator by multiplying everything here by square root of 2. So 1 times square root of 2, square root of 2, square root of 2 times square root of 2 is 2. And there's our value, square root of 2 over 2. Square root of 2 over 2 is extremely easy to remember. You just have 2 2's and then a square root on top. That's the only thing you have to know for this unit. You have to memorize these values, but honestly, making these tiny little triangles in like the bottom of your page will save you so much time or even like hassle to try and memorize these values. Like the more you work with them, the more keen you'll become to actually remembering them off by heart. But if you're in a difficult situation, or if your brain just goes blank while doing a test or an exam, those little triangles are your best friend. Don't forget them. They're very, very important. The unit circle, it's a beautiful masterpiece, but again, I would say it's for whoever actually enjoys using it. You could use the little hack I showed you to remember what the values are, but I don't think you're ever going to be creating a unit circle for a question. You need to actually remember the values that you get from the unit circle. Therefore, this is not that important to remember. Okay, now that we've finished talking about how to find the cosine and sine of everything on the unit circle, we now need to cover our last part, and that's our tangent. Our tangent is equals to, or tangent of theta is equals to the opposite over the adjacent, right? So what would the opposite and the adjacent be in our case? Well, in our case, that is equals to y over x. That is the biggest takeaway from all of this. So for any of the values you just found, you could always find the tangent by simply dividing the y value by the x value. Okay, so let's do a quick example. Tan of 30 degrees. That is equals to y over x. So our y value is 1 over 2, and our x value is square root 3 over 2. Doesn't this look like so much fun? well, let's simplify it or rearrange it. Since we're dividing by a fraction, that actually means to multiply it by its reciprocal. So what we get is 1/2 times 2 over 3. So the 2's cancel out. And we get 1 over square root of 3. Now, since we know we can't have a square root in the denominator, we need to rationalize this by multiplying everything by square root of 3. The reason why we could do this is because this equals to 1, right? So all we're doing is just rewriting what this actually equals to. So we multiply the top by square root of 3 and we get square root of 3. Then square root of 3 times square root of 3 actually just removes the square root and we're left with square root of 3 over 3. So that's what tan 30 is equals to. Tan 45 or tan pi over 4, let's actually do it in radians now. Pi over 4 again is equals to y over x. The fun part about this is if you remember, or if you have memorized this by now, the values we have at 45 or at pi over 4 are the same for cosine and sine. So since they're the same, we can always remember that pi over 4 is just equals to, what is it? 1. Since we have the same values, it just equals to 1, and we're happy little kids, you know? We don't have to do anything else. Now for tan 60 or tan pi over 3, again, we have y over x. In our case now, we have actually flipped these and we get square root of 3 over 2 divided by 1/2. That is equals to square root of 3 over 2 times times 2 over 1, which is equals to square root of 3 over 1, which is the square root of 3. So now we have completed our special angles for tangent. Now we just need to talk about pi over 2 and pi itself. So let's think. So at pi over 2, we have our y value is equals to 1 and our x value is equals to 0. So what we're doing is dividing 1 by 0, which, you know, cannot happen. You cannot have a 0 in the denominator. Therefore, it is not defined. It cannot equal to something here. So for pi, we actually get y is equals to 0 and x is equals to -1. What we get then is 0 divided by -1, which is 0. Therefore, tangent at pi is equals to 0. Everything I just talked about here, I will now summarize in a little word presentation. But again, this might seem a little bit complicated, but you genuinely just need to memorize 5 different values and 2 of which are 0 and 1, and then your life will be golden. You just need to learn how to apply them properly. Okay, so again, while learning the unit circle is beneficial, it can also become a hassle to some people. Personally, I find it a little bit of a hassle just because of how much work you need to actually do to memorize it, when you could easily just use the life hacks that I showed you to remember those values much easier. So honestly, if you're not a visual learner and you just want to memorize something off the bat, here's a simple chart that you need to remember. So here's what it is. I wrote down the sine, cosine, tangent values for several angles and their corresponding values. So for sine pi over 6, that is equals to 1/2. Pi over 4 is equals to square root of 2 over 2. Sine pi over 3 is equals to square root of 3 over 2. Sine pi over 2 is equals to 1, and sine pi is equals to 0. Now, for cosine, as I talked about before, it's exactly the opposite of what sine is. So cos pi over 6 is the same as sine pi over 3, which is square root of 3 over 2, as you can see here. Cos pi over 4 is the same as sine pi over 4, since they're exactly the same value, and we get square root of 2 over 2. Cos pi over 3 is the same as sine pi over 6, which is equals to 1/2. Now, these two are opposite again. So cos pi over 2 is equals to 0, and cos pi is equals to 1. Or actually, it should be -1. Let's fix that. God damn it. Should be -1. My keyboard is actually turned off, so I need to insert a special character. negative. There you go. Now we're happy. Percent. Yep. So cos of 0 is equals to 1. That's the difference. Then a tan, as I talked about before, it's essentially just the y value over the x value, so sine theta over cos theta, if you remember that as a trigonometric identity. So what we did was 1 over 2 divided by square root of 3 over 2, which is equals to square root of 3 over 3, once we rationalize the denominator. Then pi over 4 is just square root of 2 over 2 divided by square root of 2 over 2. Since these are the same values, that equals to 1. Then tan pi over 3 is equals to square root of 3, because again, we just divided this value by this value, and so we're done. Then for tan pi over 2, it is not defined. The reason for that is since our y value is 1 and our x value is 0, we cannot be divided by 0, therefore pi over 2 is not defined. Then tan pi is actually 0 because our y value is 0 and our cos value is -1, so just 0 divided by -1 is 0 divided by anything is equals to 0. Okay, so with that out the way, we can again use the multiples of these angles to find the trigonometric ratio in any quadrant. So again, if you remember the cast rule, this is essentially what it is. This was quadrant 1, or the A value, or the A in cast. Quadrant 2 is the S, where the S means that sine will always be positive. To find the equivalent radian measure, and what I mean by that is the pi over something value, so the angle, in quadrant 2, we can easily just subtract the special angles, which I stated here, pi over 6, pi over 4, pi over 3, pi over 2, or pi is already included in this, from pi itself. So for example, if I wanted to find what the equivalent measure for sine pi over 6 is in quadrant 2, I would do sine of 1 minus pi over 6, which is the same as 5 pi over 6. Therefore, what we have found is that sine pi over 6 is equals to sine 5 pi over 6. And both of them equal to 1/2. If I wanted to do this, for example, for cosine, I would do the same exact thinking. I would do cosine, let's say pi over 4 is equals to cosine 1 minus pi over 4, which is equals to cosine 3 pi over 4. The difference here is since it's cosine, it is not positive anymore, so we just plop a negative in front of the value. So as I said before, pi over 4 is square root of 2 over 2, so square root of 3 pi over 4 is negative square root of 2 over 2. Now for quadrant 3, we know that tan will always be positive, and the way you find the equivalent radian measure is to simply add the special angles to pi. So the reason why I have 1 here instead of pi is because I'm a little bit stupid, but you should understand that it should be pi. Essentially, again, for tangent, pi over 4 is equals to tan pi plus pi over 4, which is equals to 5 pi over 4. Therefore, we could find what tan 5 pi over 4 is. Since it's equivalent to pi over 4, we actually get that it is equals to 1. Again, if you're using this logic for sine and cosine, since it's in quadrant 3, you need to add the special angles to pi and then add a negative to whatever value you've gotten. Lastly, for quadrant 4, we know that cosine is always positive. So to find, sorry, that was a yawn. To find the equivalent measure in quadrant 4, you can easily just subtract the special angles from 2 pi. Wow, this page is full of mistakes. I need to fix it. Just give me one little second to do so. Okay, let's actually make this proper, because honestly, I'm really sorry with the amount of mistakes that just occurred over here. 2 pi, and this is 2. Are we good now? I think we're good. Okay. So if we're talking about cos pi over 3 in quadrant 4, it would have the equivalent of cos 2 pi minus pi over 3, which equals to cos 5 pi over 3. So we know that cos 5 pi over 3 is the same as cos pi over 3, which means it actually equals to 1 over 2, and now we're happy. Again, if you're dealing with sine or tan in quadrant 4, you should plop a negative. Lastly, the inverse of all of the primary functions are also extremely useful, and you'll be asked to determine them as well. The reality of it, though, is you just need to take the reciprocal of the respective primary trigonometric ratios. For example, the cotangent of pi over 3 would equal to 1 over tan pi over 3. So tan pi over 3 is equals to square root of 3. Therefore, cotangent of pi over 3 is equals to 1 over square root of 3. That's all you're doing. Just plop in a 1 over whatever value you were getting. So with that being done, this is the homework for today. It's honestly a lot of questions, but the reality of it is, all you're doing is just using these values here to solve various problems. Some of them will be asking you to just simply calculate what those values equal to. The other ones will be asking you to solve a word problem. But again, the word problem would be like, hey, do you know the Pythagorean theorem? Do you know your primary trigonometric ratios? Then you are settled. So again, I'll show you these questions in a moment, but I don't think I'll actually be solving any of them because it's just a lot of practice and applying what you just learned. Okay, so I assigned 7 and 8, which is just finding the exact values of each of these angles. You know how to do that, therefore I'll just let it be. The same exact thing is for 8. It's asking you to use the unit circle, but if you just remember how to calculate them, you'll be so much happier. Then I asked you to do question 9, which is Linda is flying her kite at the end of a 40-meter string. The string makes an angle of pi over 4 with the ground. The wind speed increases and the kite flies higher until the string makes an angle of pi over 3 with the ground. Determine an exact expression for the horizontal distance that the kite moves between the two positions. Okay, so what do we know here? We know that it's pi over 4 into pi over 3. So we could first of all sketch a graph. The question it's asking us is to first of all find the horizontal distance, which means the change in the x direction. So first of all, you know how to find cos of pi over 4 and cos of pi over 3. The reason why I'm saying cos is because we could use the unit circle or just use our newfound relations between cos theta and the unit circle to find what equals to 40 meters. For example, honestly, I'll just show you this just because we didn't properly discuss it. Okay, so let's look at this question. Imagine this is the quadrant, or this is just where, Linda is. She's flying her kite. This is an angle of pi over 4. This is her kite. Then the wind blew, and then the angle was increased to pi over 6. No, pi over 3, sorry. So now the kite is over here. We need to first of all find the horizontal distance. What do we know in this question? We know that our hypotenuse is equals to 40 meters, right? Because that's what this said the length of the string is. We don't know our adjacent. We don't know our opposite length, but what we do know is our trigonometric ratios. So for example, when we had pi over 4, cos pi over 4 is equals to square root of 2 over 2. With this, we could now find our ratio, right? So first of all, how much did we increase by when we're going to make this 40 meters long? To find the displacement that it had on the horizontal axis, all we're doing is first of all determining what the first horizontal distance was and then what the second one was, so x2, and then finding the difference. So our first distance, so x1, can be found by the following. We know that cos pi over 4 is equals to something over 40. So cos pi over 4 is the same as square root of 2 over 2 is equals to x over 40. Now we just cross multiply and we get 40 square root of 2 is equals to 2x. Divide both sides by 2 and we get 20 square root of 2 is equals to x. That's our first distance, horizontal distance that it was at. Then for our second one, we have cos pi over 3. So cos pi over 3 is equals to x 2 over 40. Cos pi over 3 is the same as, let's draw the triangle because I don't remember things that well. This is pi over 3. So this has to be square root of 3. This is 1. This is 2. Is equals to square root of 3 over 2 is equals to 40x 40. There you go. Now cross multiply and we get 40 square root of 3 is equals to 2x squared is equals to now 20 square root of 3 equals to x2. Now we just find the difference between x1 and x2. So x1 minus x2 is equals to 20 square root of 2 minus 20 square root of 3. This is the exact expression. It doesn't tell us to actually estimate what the values are. Therefore, this is our answer for A. Now, to do part B, we're simply going to be dealing with sine because that is our y value. That is our vertical distance. Next, for C, it's asking us to determine the approximate answers for part A and part B to the nearest tenth of a meter. So you're just plugging in that value into your calculator and finding out what it equals to. So we're good there. Now let's look at question 10. So question 10 asks us to refer back to question 9 and suppose that the length of the string is still 40 meters and an angle of pi over 4, but then she lets the string out to a length of 60 meters as the angle changes to pi over 3. So now it's almost the same question, but now the string was also increased. It's asking us to determine the exact expression for the horizontal distance that the kite moves. It asks if it moved closer to Linda, horizontally or farther away. Then it's asking us for the vertical, and then it's asking us to compare the altitude, and then again it's asking us to actually find the approximate answers. So for here, it's almost the exact same procedure for question 9, but now for x2, instead of saying it is equals to like x2 over 40, we now have x2 over 60 because our hypotenuse changed. Now, I've also assigned question 12, which is just a simple evaluation question. It might look complicated, but I assure you it is not. It's just testing whether or not you can apply the unit circle, or if you can evaluate the multiples of the primary or the special angles. For example, cos 4 pi over 3 is the same as cos pi plus 1 pi over 3, right? And since now we are in the third quadrant is tan is positive, so cosine has to be negative. So cos 4 pi over 3 is equals to negative cos pi over 3, and cos pi over 3 is square root of 3 over 2. Therefore, this is equals to negative 3 square root of 2. Oh, sorry, negative square root of 3 over 2. And you do that for the rest of the values, and then you just evaluate. I've also assigned question 14, which is this one. When this girl receives her bachelor's degree in mathematics, her friends present her with a radian watch. Her friends repainted the face of the watch. Instead of the usual numbers around the face, they replaced the 12 with 0 and the 6 with pi. And the hour and minute hands of the watch run in the usual clockwise direction. A radian time of pi is shown in the diagram. What is the radian time that corresponds to 3? Okay, so now we're just learning how to count. It's pretty easy. If 6 is pi and 3 is in the middle of 0 and pi, that means it's pi over 2. What radian measure corresponds to 4? Ooh, fun. Let's think. This would be pi over 6, 2 pi over 6, which is pi over 3. This is 3 pi over 6, which is pi over 2. This is 4 pi over 6, which is 2 pi over 3. So there you go. We found what that is. Then it's asking us what normal time corresponds to radian time of 3 pi over 2. So all that we know by now is that it passed the halfway point of pi. So pi and a half, right? So it's over here. Therefore, it is 9 o'clock. Now, lastly, it's asking us the normal time of 11 pi over 6. That would be our last measure, which is 11 pi over here, or 11 o'clock. Then it's asking us for 30 minutes. That might seem a little bit more complicated, but let's think. This was 6, therefore 7 pi over 6 is 7 o'clock. Now, let's convert this to 12, right? Since we're trying to find a half. So 7 pi over 6 is the same as 14 pi over 12. And to find a half, we're just adding one more pi, which would be 15 pi over 12. Next, we have our questions 16, 17, and 18. These are, again, evaluation questions just to practice your trigonometric ratios with the special angles. Nothing too difficult, just practice. With that being said, that's all the homework I've assigned for today. So again, I'd like to thank you for listening to this lesson. I understand this lesson might have been a little bit confusing. Personally, it was a little bit hard to explain, as it's mostly just telling you to, hey, remember these values and then apply them. But hopefully you understood how I got them in the unit circle. Also, if you have any questions, again, feel free to contact me. Tomorrow, or in a couple of days, we'll be covering chapter 4.3, which is just a continuation of this with a couple of new information. It's honestly fun. Everything in this chapter I find is fun. With that being said, thank you for listening to today's lesson, and I hope to see you next time. Bye bye!